I know exactly what you're thinking, that not every technical solution is the same, even if they happen to be similar. Sometimes there are specialty problems like physical location and distances that you have to solve. Well, it just turns out that we have a project just for you. Solves these problems in a very clever way and even introduces you to one of the newest Microsoft research projects that you have never heard of. That's this episode of Dev Radio. Hi, and welcome to the next episode of Microsoft Dev Radio. I'm Jerry Nixon. I'm your host, and I am excited to be here with Paul Foster, all the way from the UK, another technical evangelist. Paul, thanks for being on the show today.
Hi, Jerry. It's great to be here.
Now, let's see. You are in or near the Reading office, spelled reading office for those people who are like hilarious. But tell me a little bit about who's Paul Foster, just in case there's anybody who doesn't know.
So I'm a technical evangelist in DX at the moment. I've worked at Microsoft for over 22 years across a variety of technologies and products. And I like building things, making things, and that's why working as an evangelist is fantastic, because I help people achieve more.
Did you start out in evangelism? Have you been in evangelism for 20 years?
I started out in the business briefing team, which was technically evangelism. But I've stuck with developer, and I've worked for mobile business unit and a variety of other things. So I've done a lot.
23. You're 2 years away from 20. What do they do for 25? Do you know?
Probably take you. No, I can't say that. Sorry, I was going to say.
They give you a high five, pat on the back, and thanks for your service. That's right.
That's right. Yeah, absolutely.
That's easier to say than whatever it was you were about to dream up. What's your in evangelism now? I love talking to evangelists, and what's evangelism like in the UK? What's the technical climate around Reading and everywhere else?
Well, I guess it's like the rest of the world. We've got a lot of conversation as a platform trending up there, but a lot of automation, a lot of looking for self-service. So that's where the CAP technologies come in. But for a lot of that, we need to do instrumentation, and that's where my IoT technologies come in. You know, the IoT world is the fuel for AI as we work at the moment. So the question is, how can we economically instrument the things around us? And we're doing some cool things. The stuff we're going to talk about today is driving a lot of our industry engagement because it reduces the cost of instrumentation and enables some pretty new approaches to very traditional commercial services.
Talk to me a little bit about why we're still waiting for this, because I feel like Azure's there, I feel like the hardware is there, and yet we're waiting for all this automation, we're waiting for all this instrumentation. What do you think is the barrier, and not just in a specific industry, why are we not seeing this, just the floodgates breaking open right now?
Well, that's a really good question, and it's a great one relevant to this project, because the challenges are predominantly around the cost of the hardware materials. So at the moment we have devices, sensing devices that are coming out at fairly high cost, and that high cost is supporting those organizations. You know, that's their business margin in that device, and that's having to cost things such cover costs such as certification for those devices. So there's a lot of high cost incorporated in building a device and bringing it to market. But there are other challenges as well. So traditional wireless technologies that we might use, such as Wi-Fi or even BLE for connectivity, give us a really low sensor to gateway ratio. And that means if you're trying to instrument a large space like a commercial office building, you end up having to have a large number of gateways to gather together small batches of sensors.
And the gateways are a big part of that cost.
Yes, I mean, literally the gateway is providing that bridge from some other smaller sensor device. So the technologies we've been using this project are striving to solve that problem. And I've been building some devices that we'll talk about in a little while that move us to more inexpensive sensors with longer battery life.
Hey, there's some fascinating things here. One is if I were talking to just the average cat out there and I was saying, these devices are pretty expensive, and they were to ask me, well, how expensive are they? And I say, well, they could be $40. And they're like, why is that expensive? I think a lot of people don't wrap their head around that you could buy 100,000 of these, and suddenly it's very, very serious. And now we have, you mentioned certification, and we have a whole handful of regulations and security concerns that can take a $40 device and double it to an $80 device instantly, just because maybe it also needs to be underwater and it needs to be able to withstand a whole bunch of heat or whatever it is as well, right? All these subtle things where you're like, now I've taken what, I could buy that sensor for 30 cents on eBay. Well, that's great, but that sensor is useless without all of these other pieces, which bring it, and now we're almost to $100 for those, and I still need 4 million of them. And so, it's just going to be this enormous thing that I'm going to have to overcome. And so it seems like a small cost until you realize the scale of IoT. And I think a lot of people feel like IoT is a Fitbit on their arm, and they just need to buy one, and they don't realize that it's an enormous concern.
Yeah, I got some good examples for you in terms of, we're working with some commercial companies that want to instrument buildings for people. And when I say buildings, I'm talking about not only the toilet blocks, but also things like confidential waste bins. Now, one of the customers that we're looking to work with has 500 confidential waste bins spread across 33 floors and well over 60 sort of toilet blocks in that scenario as well. And as you start to try and instrument every waste bin in a way that's more economical than having cleaning staff members walk around on an hourly rota to check the bin to see whether it's empty or not. We've got to drive the price point down. There are a lot of commercial issues. Labor costs are, for example, continuing to rise. So particularly in the facilities management world, customers are looking to deliver a high quality of service, but at a good price, and they want to utilize their most skilled asset, their labor, in the best possible ways. I mean, it's pretty dull just walking around checking bins, but if you can be utilized to do a lot more creative things, because you can be directed by when bins are ready to empty and when facilities are needing other maintenance tasks, or your customer needs support. If you can be driven dynamically to do that, then that team member's job is far more interesting, far more engaging, give them a great way to move forward. And that, of course, improves the whole service experience for the recipient customer anyway. So there's a lot of positive things there in terms of, giving people a lot more to get on with, being more efficient in doing that, and being clever. Having some, I'll call it AI for the moment, but also we know it breaks down into some machine learning models, and it breaks down to SLA agreements that are captured in the cloud and encompassed in these models. And of course, those models are then fed by the instrumentation data from IoT devices, and then the models are delivering instruction, typically to a wearable device, that the cleaning staff or the member of staff is wearing. And that just means that, the service company can say, yes, we did meet your SLA requirements, and here's the data to prove it. But it also means that, they were able to excel at that service delivery and be where they needed to be to do what they needed to do.
I feel like clever. I'm so glad you used the word clever, because I feel like clever is the new low bar. Like, if your company isn't being, you don't have to be ultra complex. That's not the same thing. If you're not being clever in the way that you're utilizing what you have, it is, well, the clock is ticking for you, is really what it is. And I think it's very fascinating. You made this awesome point around labor, and that labor costs are going up. And I was just at Disney World. I didn't know this. Disney is making also a sensor for their trash to be able to detect whether or not trash cans are open or full, because there are so many trash cans there. And I'm like, wow, are they just doing this for fun, just so they can say they're high tech or not? And not long ago, I was in India, and there was a water tower, and it was an ancient water tower, and I asked what I thought was a simple question. How did they get the water in there in the first place? And the tour guide just kind of smiled in a "you're so dumb" sort of way, and said, labor is not a problem in India. And at that moment, after recovering from the mortal embarrassment, I was like, aren't they lucky? Because the rest of us, we don't have this crazy luxury of labor is such an easy thing to come by. And then guys like you start making it harder on us, because now I don't need to go check 2,000 trash cans. I need to check 2,000 trash cans and 6,000 monitors that I have and all of these other things and all these gateways and things to check. And now you blow it up like this and the labor stays somewhat static, if not going down just a little bit. And so now Clever really comes in as the savior, because we are either backing ourselves into a corner or we're going to solve this just by thinking smart about it again. And I think it's exciting.
It is exciting, and there's yet more, because instrumenting static things is only the beginning, and some of the cutting edge stuff that we're now involved in is literally using mobile robotics, so that things like patrols, they are now can be run and controlled, if you like, by a mobile command base, which is your night security guard. But now he's got delegates, which are these robots that are, operating, checking, and they're doing other building service things. So, they're equipped with cameras. They're recognizing that there are fire extinguishers in place, that fire exits are closed or open in error or blocked. So all of these things become just IoT telemetry data once we've done the processing. And certainly the project we're going to talk about today is our first start, if you like, at defining that sort of architecture and this sort of solution for the facilities management industry, enabling them to start taking advantage of all these cool things.
Okay, well, let's do that. Let's talk about the problem we're about to solve, because interestingly enough, this is not a unique problem. Everybody not everybody, but lots of IoT-oriented industries or solutions bump into these problems, and there aren't a lot of solutions for them. But you have a couple of novel ones that aren't unique because it's you, but unique because this is what we used in this project, and it's pretty cool. Talk to me a little bit first. How do we meet the customer? Who is this partner?
Okay, so I work a lot with the Microsoft ISV ecosystem, helping them achieve more with cutting-edge technologies. And one of the great partners I've had the pleasure to work with almost across my 20 years at Microsoft has been an organization called TBS Enterprise Mobility. Okay. And TBS came to us and said, hey, we've got an interesting challenge. We need to instrument this site, and the site's pretty far apart. What have you got that could help us do this? And they introduced us to the Emirates Air Line cable car. So this is a cable car that spans the Thames in London. It's a 1.5 kilometer crossing between the Greenwich peninsula and the Royal Victoria docks, where people might be recognise XL, the large London exhibition centre. And it has, 36 cable cars, gondolas that go around over this, and obviously the two stations on each side. And they wanted to, get more data out of, their end-to-end system, so that they could start moving on this journey of predictive maintenance that we understand. But they also wanted to, increase customer comfort and customer service, and look to expand their commercial operation, or their commercial opportunities, I should say, in running the cable car. So the cable car, I should point out, is part of the Transport for London infrastructure, and it's actually operated for Transport for London by the Mace Macro group. So we were working with the Mace Macro guys on the ground, and with TBS as the development team, and supporting them building out a solution. Okay.
Talk to me about, give me the high level of the solution, because I still want to, what was their core problem?
Okay, so the core problem was getting more real-time data for the volume of usage. So they got a number of people passing through the system count at the end of every day from the existing Transport for London, which are probably called TfL. It's easier to say
Okay.
TfL. So TfL would provide a report maybe the next day of how many people traveled on the previous day. And they really wanted to know who's traveling at what sort of peak times across the day. And that all links to the maintenance cycle of the cable cars. And then there is actually the operation of the cable car, and it turns out that they can speed it up and slow it down, and they do so based on the volume of people in the cable car and the temperature and the environmental condition in the cable car, because these cable cars are running on battery power. So you can't just have your AC running all the time, So if it starts to get hot or it starts to get really cold, they'll speed the cable car up so that your journey is shorter and, you're able to do so in comfort. But they needed to get more real-time data. They had a limited radio signal that did give some CCTV frames, with quite a long duration between them. But they didn't get a lot of other sort of real-time data out of the cable car. And also the cable car houses an infotainment system. And that infotainment system can only update itself in short segments as the cable car literally passes through one of the stations. So performing any large upgrade, to the content, and so on of the infotainment system, takes a fair time because all 36 cable cars take a chunk as they just pass through one of the lead stations as they turn around. So
what's the time duration in general from going from one side to the other?
It's somewhere between 10 and 15 minutes.
Okay.
So it's quite a nice journey. You're sat there over the Thames. You can see, all the sights of London laid out before you. So I thoroughly recommend it if you're in London. So there was an instrumentation of the cable cars, and there was a further instrumentation of the stations. And of course, there's one station where all the connections to the world, if you like, existed, and that's on the Greenwich Peninsula. And then there's sort of the second station, if you like, on the Royal Victoria Docks side of the river that's not got a lot of functionality. The machine room is in the Greenwich side. So the challenge is, how do you actually deliver service across the length, the 1.5 kilometers of the crossing?
Right. Now, let me ask you a couple of questions around that are kind of they're begging in my mind here. If I'm taking this 10-minute, 15-minute journey, can I talk on my cell phone the entire time? Is there a cell connection during this?
It actually turns out that we're on the wrong side of the O2 for the cellular connection. You can get a cellular connection, but it's not the best cellular connection for that crossing. So as you hit the Victoria Dock side, it does become residential. There is some business and things there. But the O2 side tends to have a small or a cluster of Pico services to service the arena. So if you sort of mean, there's less of a cloud coverage service across that river space on the side where the crossing actually is. So you can achieve a level of, certainly a voice call, but your data service there.
But a reliable, you're right, reliable data connection is not something I'm going to get over the cell service. So that's the problem, right? The problem is, all right, you need to be able to talk to this cable car full time so that you can get more data out of it, more reliable, and you want to do other things as well, but we can't use cell. So you come into the picture and you say, tell me.
Yeah, so, well, I mean, just on that point, just at the very beginning, we can't use cell as well because it is a battery-powered car. And if you hold up your cell connection with data, which is one solution, you are hitting that battery harder. As we all know, if you use your cell phone and you stick on data for that, commute, by the time you get to the office, you're seriously dented your battery, right?
Yeah.
So, these cable cars are only able to pick up a small amount of, recharge as they're passing through that station, and they pass through that station in like 30 seconds. So, they've got to survive for a long period of time. So the battery power is the key thing. So we needed to facilitate all of this minimal power.
And Paul, you have to come up with a solution that doesn't say change your whole business model and change the way that all of this engineering already works. You need to fit into what's already going on.
Absolutely right. Absolutely, got to fit in there. So Well, what we first did, which was a bit of fun, is that I built out a couple of LoRa WAN radio sensors. So they're actually using LoRa to begin with. So LoRa is the radio modulation that enables us to have a low power, long range, low bandwidth connectivity. It's a cutting edge new technology that's coming out. And I built a couple of these devices using dev boards, and I got to place one in what I call the James Bond fighting zone, where all the wheels are in the cable car system. So I was allowed to go up into this high space where I had the best line of sight across the crossing, and I was able to hang my small device there. And then I was able to go down, jump in a cable car with my second device and sit there and just watch transmissions. And without doing anything else, I was able to achieve, sensor connectivity all the way across the crossing and back again. So that was a really fantastic kind of my first experience in getting into LoRa.
Plain dunk, first try.
Absolutely, top on. All with only 8.2 centimeters of wire aerial as well. Nothing super elaborate there. So that
probably very minimal battery use as well. So it was really the beginning of a possible solution.
Absolutely. I was running from 2200 milliamp LiPos, which are, really quite small and thin, and that they run these devices for ages. I use them day in, day out, again and again and again, and I charge them, every other week kind of thing. So they're going for long, and that's unoptimized. I've got some other bits I want to show you where I'm working towards sensors that will give us multiple years, because that's what we need. So,
boy, that's incredible, actually.
So we ended up with the plan of using LoRaWAN. Now, just to get that in perspective for you, LoRa, as I said, is the radio modulation, and then above that, we now have LoRaWAN. And LoRaWAN is, if you like, an OSI layer 2, 3 MAC level protocol. So it's giving us some MAC commands to abstract us from just the LoRa functionality, and that enables us to do some more significant things with different classes of device using the LoRaWAN network. LoRaWAN networks are a star configuration. The gateway's in the middle. All the devices are going to that gateway, and it has a variable or adaptive data rate. So the further you are from the base station, the slower your bandwidth or the less bandwidth you'll have, but the stronger the signal transmission will be. So as you move closer to the actual gateway, you speed up in terms of the volume of data you can transmit, and so your transmit time's shorter. And as you move away, you work harder with a greater power per bit, if you like. Your transmission rate slower. So it's a really fantastic technology, and in perfect conditions where you've got line of sight to between your sensor and the gateway, you can end up with 15 kilometers of coverage, which is phenomenal coverage for sort of sensor IoT devices.
Yeah, and then but when you put this in the James Bond location, that was on one of the cars, but I guess you had then other gateways at each of the different edges, or what were you communicating to?
So I only need one gateway in the Greenwich Peninsula. That was where in the fighting.
Oh, because 1.5 kilometers is such a small area for LoRaWAN.
Correct.
I see.
So there's given that we're crossing the river and there's no urban density to that river, there's no obstructions to obscure the signal. Just one gateway in a suitable location on one station gives us the range we need to be able to instrument all the cars and the other end of the station. But that's not all the solution, because LoRaWAN has a very low data rate. We're only talking bytes, with a byte per second. And in the UK, we're quite strictly regulated on the duty cycle. So if I give you a little background around LoRaWAN.
Sure, Paul. Give me just a little bit about LoRaWAN's background so I can understand it.
Okay, so LoRaWAN runs on a set number of frequencies across the globe, slightly different between the United States and Europe and Australia and China, for example. but they have a duty cycle on the frequency usage. So certainly in Europe we do, and that means that we can't transmit data more frequently than maybe 1% or 0.1% of the possible available time. So that's why our data rate is not just low, but we might only transmit data every few minutes. You're not going to stream, things from that.
So I'm not going to be able to watch a CCTV inside by any stretch of the imagination.
No. So we needed a second network to give us that, medium bandwidth and still cover the range that we had at the crossing. And that's where Microsoft Research Cambridge Lab came in because they have a TV whitespace network that they've been developing. And so the TV whitespace network just nicely comes in with a range large enough to cover the 1.5 kilometer crossing, but it's delivering us something like 6 megabits per second. So now we're actually better in our connectivity. So this gave us the opportunity to start hanging off, some interesting other devices in the station. Now, the research guys really wanted to prove that their network could deliver that sort of throughput and keep going. So what we came up with was let's actually have some IP CCTV cameras that can essentially stream the feed across the TV white space, and then we'll do our analysis in the cloud of that data. So those devices, in the real world, we're going to scale out and we're going to, move the intelligence maybe into the CCTV device. But for this particular hack project, it gave us the opportunity to test the network. So we ended up building our computer vision analytics as services in Azure. And we framed those as smart IoT devices. So today we might talk more about intelligent edge devices, and that's where we certainly are in our device build. But back in last year when we were building out this architecture, we thought we'll stream so we have a constant network load, and then we can evaluate the network performance and give MSR, Microsoft Research, some data back.
What's the hardware requirement for using TV whitespace? Which I know one of the things that MSR is using TV whitespace is to bring the internet to rural areas as well, where it's just impractical otherwise to reach. Even in Africa, we have a whole story that I've read out, and it's inspiring. But at the same time, what do you need? Is it a standard antenna on the device that is transmitting? And what do you have at each of the sides, or just one of the side? And what do you have there?
So again, you're only transmitting from one location, and the antenna is actually pretty much off the shelf antenna. It actually is a device that if you imagined an old 15-inch luggable laptop closed, that's kind of the size of the thing. I can't talk too much yet about the other stuff. The other stuff is really interesting, but that's still secret source, as it were, that MSI aren't quite yet sharing. So we have to.
You can tell me it's amazing. You can describe it in those words. It's awesome. It's neat. It's clever.
And potentially, you've got a fairly succinct single small device that you need to use on site. So that's pretty cool. So we ended up with the TV whitespace just needing an internet connection on site and a mains point. The LoRaWAN gateways only needed a mains point because they were already integrating back into the TV whitespace, and even our smart CCTV cameras only needed a mains point, a mains power point, because they're wireless back to TV whitespace. So you can see that we can now rapidly instrument the stations with that sort of I just need mains, just give me electricity, and all these things are going to run from that perspective. The LoRa side, though, again, as I mentioned, is we're down to battery power, and we're down to running off coin cell batteries, the classic CR2032, and obtaining something like multiple years. I'm aiming for 3 years because 3 years is a typical facilities management contract length. So if you can imagine you're instrumenting a new customer, at the end of the 3 years, where you either go around and change the batteries, or you just you can walk away because they're so insignificant in cost.
Fascinating. Wow. So that low battery of power cost. Wow, that is incredible.
Yeah. It ended up with very small devices. You obviously are doing some great embedded development because you're looking to, compress any data that you're sending, but you're also looking to transmit it as fast as possible and turn the radio off.
Mm.
Yeah.
Paul, tell me, what did devices like this look like?
I can show you.
Okay, Paul, I can see your desk. What am I looking at here?
So, well, the first one is the yellow box. So this is the actual device I hung in the James Bond fighting zone originally. So it is actually a Cortex M0 device under there, but this one has not a typical Win 1500 Wi-Fi chip in it. It's got a LoRa chip in it, and that LoRa chip, I've modified the circuit with a little jump wire. So that we can actually get the interrupt from the radio SOC to see the proper functionality of the LoRaWAN. But essentially, this little device with its OLED screen is able to do the transmissions I need to do the test. So that's a great little environment. This one that I'm going to show you now, this is a certified device. So this is a Multitech M.Dot in its dev board. And this is a sort of device that we'll actually probably use. It's got a full, or it's got a quarter-length aerial on it, which is much more significant. We don't need to use that. But it does mean that I've got a certified radio board that I can use. So that's important in the production of commercial devices. It gives us a jump start. But where I'm going is playing with this little board. So this is a great little PCB. Printed circuit board that I found on OSH Park, and it was manufactured by Brandon. But basically, I've put this together, so I'm particularly pleased with my surface-mounted soldering to get a 32U4 chip on there and running. And then I'm using this standard radio SOC, which hopefully you can get to see there, and you can see the CR2032 battery piece. So this is the size of a key fob. And yet I've got a processor on there that can, derive data from a variety of input devices, analog or digital, compress it all, encrypt it all, and deliver it over, the classic 8.2 centimeters of wire aerial, which is
Talk to me a little bit about what would you expect for the production cost of those three devices to be?
Yeah, so... well, if we talked about the M.Dot and the actual the pieces, the raw pieces that I'm working in terms of bill of materials, the M.Dot as it is in a release device, I think that the whole dev kit you see there, it comes in at still at about £140, but you obviously don't need the USB adapter when you're just using the M.Dot, so you can bring that price down to somewhere heading towards half of that. Okay. Still expensive, you can see that. Now, if I move to the piece I'm building up, that radio SOC there comes in at my hobbyist prices of just under £8, but at volume you can get it down to £5. And likewise, the Atmel 32U4 hobbyist prices are maybe £4, but the volume price is less again. And you could use, one of the Cortex chips in place of that and probably achieve a better price reduction. Nonetheless, I'm looking at a prototype sensor that's costing me sort of £10-11. Yeah, and if I took that through certification and then into manufacturing, you could expect the volume pricing to go lower than that. So we are seeing tenfold decreases in IoT pricing. And when you actually get down to the nuts and bolts of it, obviously, the prices are very affordable, but, we've still got that sort of certification liability cost that you've got to sort of incorporate into that sensor piece.
Sure.
So,
well, there is a cost of doing business. We're not trying to get to zero. We're just trying to make it reasonable.
That's right, absolutely. And then if I just gave you a little example there, this is just literally a device that I built. It's not one that we've used, but it's one that I was playing with to demonstrate things. This is just a very small sort of, 4-inch CCTV housing, but inside there is a Raspberry Pi Zero W, which can connect to Wi-Fi. So Raspberry Pi Zero is the smallest of the Raspberry Pis. It's, matchbox size kind of thing, and it's got the Raspberry Pi camera in there. So all of that is in there. Now, what's interesting there is that the Pi Zero costs something like £8-9, and the camera maybe costs £20, and the case costs a few quid. So but that becomes a device that just needs power, and then you're actually up and running on as a sensor device, a smart sensor device through to the cloud.
That's right. And then I suppose as a business, you get to decide if you want something expensive and rugged or inexpensive and easily replaceable.
Yeah, absolutely. And as we push the prices down, these things are becoming disposable. We are already seeing, agricultural solutions where sensors are included in the sacks of fertilizer. And therefore, they are entirely disposable from that perspective.
This is all very cool. Anything else?
Yeah, well, I just wanted to show you the multi-tech conduit device that we're using as a gateway. This is an MLinux-based device. It's about the size of a typical Wi-Fi router, but it's running on LoRaWAN, and you can actually add to it various boards to give you the connectivity into other maybe exotic networks. The really cool thing here is that I'm building out using the Azure IoT Gateway SDK, the direct integration of this device into IoT Hub. So this would mean that you can just place this device in an environment such as an office block or wherever, and it'll then connect via a backhaul like Wi-Fi or wired Ethernet straight into IoT Hub for all your IoT devices. And this is sort of something less than £500 configured.
Sure. So and then how many devices would that be able to accommodate?
Well, the gateway in LoRaWAN can listen across 8 channels that each channel has at least 6 spreading factor sub-channels across them. So that means in a properly implemented solution, you can achieve towards 10,000 sensors against this one gateway.
Okay, so just about the number I was hoping you'd say. That's a big number.
It's an extreme number, and you do have to be careful in your programming of the sensors and their expectations to participate on the network with all the duty cycle stuff we've spoken about. But that is the sort of thing that you're able to do. And therefore you can see that when I say, compared to BLE and Wi-Fi, the sensor to gateway ratio is significantly different. And I've got a great little slide I'll show you that has me testing this in the Microsoft UK campus, and that campus consists of 5 buildings, and I placed the gateway on the second floor of the of building 2, and then I walked around with my yellow box, and I got full coverage in building 1, building 2, most of building 3. Now these are multiple floored, densely packed with electronic devices and partitions and even electronic countermeasure cladding, and yet the signal passed through very significantly. In fact, outside of the buildings, the parkland and the car parks around the campus were also covered with LoRaWAN functionality. So that left buildings 4 and 5 uncovered. So if I added a second gateway, they can happily overlap, and so 2 LoRaWAN gateways in the entirety of Microsoft's UK campus could be instrumented using those devices.
Yeah, that is definitely impressive. Wow. Okay, Paul, very neat stuff. What did the customer think of this solution?
Well, the customer's excited about the potential of the solution, because suddenly we are reducing that instrumentation cost while also increasing opportunities for them achieving more commercial value. So there's a lot of potential here that we're only starting to mine now. But we've got a good, solid foundation in the architecture. The 2 overlapping network technologies provide us with a terrific range of opportunity. Our smart sort of sensors enable us to monitor pedestrians, monitor traffic, or monitor any other sort of device things. And the low-cost sensors provide a way of getting that raw data that we need to feed our AI skills.
You know, I have to say this is all pretty fascinating because there's a difference between the Raspberry Pi I have on my desk that's monitoring the temperature, and I take a hairdryer, kind of blow it so I can see it changing, and maybe I even put it up into Azure, and how exciting is that? But then the real world, there are a lot of physical limitations, and it's fascinating. You've got to think about a lot of new things. If there's a developer watching right now and they're like, wow, Paul has nailed it. I want to do whatever this is. And they come and talk to you and you're like, where do I even get started? Where do you send developers like that so that they can start to learn about some of these really niche kind of technologies?
Well, I think there are 3 locations. I mean, the first thing to recognize is just how simple the Azure IoT hub infrastructure enables you to achieve that back end.
Okay.
And that is really straightforward, and it is really simple today. And if you can't get your prototype solution up in a day, then you're doing something wrong. Okay. And then there's the specialist technologies. So the LoRa Alliance website gives you a lot of background, a lot of detail into the LoRa networks.
Okay.
It talks about the regulation and certification that you need across the different geographies. So that's a really cool place. But I'll point you actually to an open source and crowd-funded site as the final place to go and get inspiration. So this is the thingsnetwork.org. And the Things Network is literally the open source crowd-funded demonstration of LoRa. It currently runs across 86 countries with just short of 18,000 members. And there is a terrific wealth of technology skill and tutorials and labs and how-tos on their site that enable you to actually go and say, you know what, I can build the sensors that I need to drive my sensor web through to the ease of Azure to be able to then consume that data and do something of value with it.
Yeah. Wow. And then one last thing is, where do you send a developer who wants the MSR TV Whitespace SDK?
Do a search for Microsoft Research Dynamic TV Whitespace Technologies, and you'll see that. But fundamentally, while we're waiting for that wonderful technology, you can play on Wi-Fi and then dream of the range and simplicity of TV Whitespace.
There it is. There is something cool about using a technology that is yet to be available to everybody else. Definitely cool to be able to talk about it. Paul, this is pretty neat stuff. A fascinating customer with an unusual, yet not crazy, problem to be solved, and solved in a very reasonable way. Thanks for talking to me about this and kind of stepping me through the architecture of the solution.
Hey, pleasure, Jerry. It's great fun to share all this stuff, and even more fun building it.
I'll bet it is. All right, we'll see you again.
Cheers.